Let's talk about dimensional analysis and conversion factors. So dimensional analysis is going to use the units from a given quantity or measurement, just from the problem. It'll be given to us, and it will use a conversion factor to extract useful information or to swap conventions, say from the SI system or metric system to US or back and forth. Okay, so we can swap conventions or we can extract useful information. For example, if I'm given a density of 0.323 grams per milliliter and I want to know, so this is given, and I want to know what is the mass, then I know that I've got to multiply the units by milliliters so that they cancel out and I'm left with grams. Okay, I don't need to know the formula of density equals mass over volume if I'm given the units, because I can figure it out using dimensional analysis what I need to do to get what I'm going for, what am I desiring in the solution to the problem. So I can use those units and a conversion factor. So what are conversion factors? Well, conversion factors start with us being given a unit. Okay, and so the conversion factor itself that I'm going to surround with this blue box here is going to have a new unit in the denominator, which is exactly equivalent to the old unit, the given unit, in the denominator. And the whole point is something divided by itself is equal to 1. So when I multiply and divide, I'm left with a number, a new number, and a new unit. And the whole point is a conversion factor. We're assuming, for example, here's one that we need to learn for the course. We know that 2.54 centimeters is equal to 1.00 inches to 3 significant figures. And so I can make a conversion factor. Since these two quantities are equal, I can divide both sides by either quantity. I could choose to divide both sides by centimeters. 2.54 centimeters would give me 1 equals 1 inch over 2.54 centimeters, or I can go the other way and I could say divide both sides by inches, by 1 inch, and I would get 1 equals 2.54 divided by 1 inch. Okay, and so the point is, if I multiply this whole quantity equals 1, since it equals 1, I'm not changing anything about it. I'm just converting from one unit to the other. So let's see this in practice. Let's do an example. How many kilometers per hour is the speed of light? And so we're given that the speed of light is 3.00 times 10 to the 8 meters per second. And what do I want? I want kilometers per hour, not meters per second. So I'm starting with a unit, and I want to get rid of that unit, so it has to go on the bottom. And what do I want to convert to? Well, I want to go from meters to kilometers. And so I can cancel the meter units, but I need to know a conversion factor. What equals what? Well, that K on kilometer means 1,000. Okay, so I can substitute 1,000. There's 1,000 meters in 1 kilometer. I learned that from my prefix table. So there's a good conversion factor. This one works. There's our first conversion. Okay, and then we keep going. Well, I've gotten one part of this. I'm there. The next part, I want to get to hours. Well, I don't have hours. Okay, I can go directly to hours if I know how many seconds are in an hour, but let's just say, let's get rid of the unit we don't want. So I put it on top so that it divides second by second to give 1. And then I can go to minutes. I know how many seconds are in a minute. There's 60 seconds in 1 minute. So these quantities are equivalent. Conversion factor 1, conversion factor 2. I can keep going. Well, now I'm rid of seconds, but I don't have hours yet. I need one more conversion factor. And so I want to get rid of minutes. So I put minutes on top, and I want to get hours. 60 minutes and 1 hour. Minutes goes away, and when I simplify down, the only things that don't cancel: kilometers on top, hours on bottom, and now it's just a matter of multiplying it out. So in our calculator, one thing that I wanted to point out that I didn't before is that we can punch this in usually by saying 3.00, capital E means 10 to the, means time 10 to the, and then positive 8. Okay, that's one way we can put that in the calculator, so make sure we're practicing that. But let's punch it out. 3 times 10 to the 8 divided by 1,000 times 60 times 60. So I should get 108. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 zeros. Really big number. And we can put that in scientific notation. Here's our decimal place. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1.08 times 10 to the 9 kilometers per hour.